Magnetic phenomena were first observed at least 2,500 years ago in fragments of magnetized iron ore found near the ancient city of Magnesia. These fragments of iron ore attracted substances like steel, iron, nickel and cobalt and were called magnetite. Greeks discovered the magnetic property of iron ores. This natural magnet was used by mariners for navigation and was called lodestone. Materials are classified as magnetic and non-magnetic materials. Iron, steel, nickel and cobalt are magnetic in nature, whereas wood, rubber, glass and plastic are non-magnetic in nature. Properties of a magnet. Attractive property. A magnet attracts magnetic substances like iron, steel, nickel and cobalt. This property is used to separate iron from a mixture and also to remove iron filings from the ice. Directive property. A freely suspended magnet always aligns itself in the north-south direction. This property is used in the construction of a mariner's compass. Poles exist in pairs. If a magnet is broken into two parts from the middle, then each part is found to be a magnet. Magnetic property is maximum at the poles. It is found that the property to attract magnetic substances is more at poles. Laws of magnetism. Let us perform an experiment before stating the laws of magnetism. Suspend a bar magnet as shown here. Allow it to come to rest. We observe that the magnet aligns itself in the north-south direction. Bring the south pole of another magnet near the south pole of the freely suspended magnet. We observe that the south pole of the suspended magnet moves away from the south pole of the second magnet. Now bring the north pole of the other magnet near the north pole of the freely suspended magnet. We observe that the north pole of the suspended magnet moves away from the north pole of the second magnet. Thus we conclude that the like poles repel each other. Let us now see what happens if unlike poles are brought close to each other. Bring the north pole of the second magnet near the south pole of the suspended magnet. We observe that the poles attract each other. Now bring the south pole of the second magnet near the north pole of the suspended magnet. We observe that the poles attract each other. This shows that unlike poles attract. That is, we can summarize the laws of magnetism as like poles repel each other and unlike poles attract each other. Magnetic keepers. When two magnets are placed side by side, there will be either force of repulsion or attraction between the poles of the magnets. This weakens the strength of the magnet. To prevent this, the bar magnets are placed side by side with opposite poles adjacent to each other, and two pieces of soft iron are placed across the poles of the magnets as shown here. Then a small strip of wood is placed between the magnets. The soft iron pieces are called magnetic keepers. The soft iron piece provides a path for the magnetic field lines to form a continuous loop, thus preserving the magnetism.